Hello students, welcome back. So in this session, I'm going to be showing you how you can generate some random numbers using random library. So sometimes you have to generate random numbers. It can be random integer, or maybe it could be random choices from certain items you have in a list, or you may actually have to shuffle some numbers. So there are different ways you can actually do that. Now, for some of the mathematicians, they might be interested in knowing how to generate a random number from a normal distribution, or from your binomial distribution, or from Poisson, or from uniform distribution. So I'll show you in this class now. Okay, first thing you want to do is import your NumPy as NP. So import my NumPy as NP, run this. All right, great. Now, let's say you want to generate 5 random numbers. Okay, let's generate 5 random numbers. All right, let's run this, and there you go. It generates 5 random numbers. And the way you generate 5 random numbers, you just call this np.random.rand. Okay, and this will generate 5 random numbers. Now, if you look at these numbers, they're going to be between 0 and 1. Okay, that's the number. They're always going to be between 0 and 1. And here's another problem with this. If I run this program and look at my number right now is 0.113, right? If I run this program again, look at this. Now it produces a different set of random numbers, right? If I run it again, you're going to see a different set of random numbers. And you see that your number is different now. Each time when I run this, it produces a different set of random numbers. So that could be a problem. Maybe I want to reproduce my numbers. I want to make sure that each time I run, it gives me the same random numbers over and over again. And you can actually get that using random seed. So step 2, and we're going to run the same program, but this time I'm going to do random seed right here, np.random.seed 78. So 78 basically is a number. I can use any number, so I'm just picking up 78 right there. And what it does is going to generate a unique set of random numbers that's associated with this 78. So each time when I run this, as you can see, it generated 5 random numbers. Okay, and these are my 5 random numbers right here. Now if I run this program again, this number is not going to change. These 5 random numbers, they're going to be essentially same. And watch this. I run this and you see that my numbers are exactly same. Run it again and see that my numbers are same. Okay, now I can use a different random seed now. So by using a different seed now, I'll generate a different set of numbers, different set of random numbers. So this will generate a different set of random numbers. If I run this, and there you go, it generated a different set of 5 random numbers. So as you can see, this random number is different from this right here. And I can keep running this every single time. And each time when I run, it's always going to give me the same number. As you can see, it's giving me the same random numbers. It's not changing. Okay, now I want 50 random integers from 1 to 7. Well, I want 50 random numbers from 1 to 7. You can do that too. So all you have to do is use np.random.randint. Okay, that's what it is, randint, and you specify your first value and you specify the last value. Now remember, your 8 would be excluded, so it's going to go from 1 to 7, and it would not include 8. And I specify my size. I want 50 of them. If I run this, it's going to generate me from 1 to 7. Okay, and there will be 50 random numbers. And as you can see, there are total 50 random numbers. You can count each one of them, or you can just take my word. There are 50 of them, and all of them are between 1 and 7. Sorry, between 1 and 8, and 8 is not included. Okay, now let's say you have items. Okay, these are your items: kiwi, banana, cherry, apple, and you want to have a random items. Okay, you want to have a random item from this one. So come over here, paste it. All right, you want to have random choices from these items. Okay, so how do you do that? Well, you use this method, np.random.choices, and over here you specify your items, which is this items right here. Okay, specify your size, like what is the size you want? 6 of them, right? You want 6 elements. And replace, do you want replacement? So if you do replacement, that means you will end up getting some duplicates. Okay, so as you can see, banana, banana, banana is getting repeated 3 times. Kiwi, cherry, apple. So I'm getting 6 of them, and I'm saying replace equal to true. Okay, you can actually change the number, and if, by the way, if I run this again, watch what happens. It's going to give me a different one. Okay, and again, if I run this thing, now it's going to give me different choices. So it's giving me different choice because I'm not using np.random seed right now. But if I use the np.random.seed, with the number in between in the parameter is going to give me the same choice. Okay, now let's do with replacement. So in this case, I'm going to do with replacement. So this function is essentially same as this function, except now I'm specifying my numbers. I'm saying give me, okay, random numbers, okay, from between 1 to 9, size is 6, and replace equal to false, meaning don't do any replacement. So if you run this, you can see it's going to generate 451,290. Okay, there's no replacement, so you're not going to see any duplicates over there. All right, now let's generate a random sample of head and tail. Okay, maybe you want a head and tail. You want to simulate some type of experiment where people are basically tossing coins. So let's say you want to generate a random sample of head and tail, and head and tail with 70% chance of head. So you want 70% chance of head. So let's define our outcome and their corresponding probabilities. So let's say my head I want 0.7, 70% chance of head, and tail is 30% chance. Maybe the coin is basically loaded, it's not a fair coin. Alright, so define your outcomes equal to head and tail, and then you define your corresponding probability. For my head, the probability is 0.7, for tail, my probability is 0.3. And then you call your np.random.choice. You call your np.random.choice. Specify your outcomes. How many you want? 20. So you specify your size. And what is your p? P stands for probabilities. Specify your probabilities, which is this right here. Alright, so now when you run this, it's going to give you your head and tail and head and tail. And if you count, approximately 70% of them would be head and 30% of them would be tail. So this way you can generate head and tail, where 70% of them would be head and 30% would be tail. By the way, it is not limited just to only 2 items. You can have 3, 4, 5, 10 items over here, depending on how many you want. Just make sure these numbers, okay, you have a corresponding number for each one of them, and they should always be equal to 1. If you don't equal to 1, you're going to get an error. So if this is 0.7, this should be 0.3, because 0.7 plus 0.3 equals 1. So just be aware of that. Alright, let's shuffle an array of numbers. So let's say you want to shuffle. You don't want to generate random numbers, you want to just shuffle. Well, you can do that too. So let me just remove this. Alright, so let's shuffle an array of numbers. So array is np.arrange number. Okay, and then I print my array right there. Okay, it prints out my array, and then I shuffle them. And the way you shuffle, you call np.random.shuffle. You call this inbuilt method shuffle, and you pass in array, and then I print my array again. And as you can see, after I print my array, every number has been shuffled. So this way you can generate a shuffled array of number. Likewise, you can also generate, okay, a shuffle array of items. So in this case, let's shuffle an array of items. These are my items. Okay, items are kiwi, banana, cherry, apple. So I'm printing my items first, and then I'm shuffling them. Okay, shuffling them the same way I shuffle this. Okay, same method, and then I'm printing my items right here. So when I run this, it's gonna give me kiwi, banana, cherry, apple, and it's gonna shuffle them. Okay, shuffle item, apple, kiwi, banana, cherry. So this is called shuffling. Now, sometimes you may want to sample from a distribution. By the way, this topic is for mathematicians now. So let's say you want to sample from a distribution, and let's start with normal distribution. Okay, so you want to sample from a normal distribution. So step one, first you want to make sure that let's try to work with a small size. Let's try to work with 5. Okay, and I want a normal distribution. Now if you remember, some of you actually who are studied math, you will remember that normal distribution has a mean value 0, standard deviation 1. So the way you generate numbers from standard normal distribution is you say np.random rand n. Okay, n stands for normal, and you specify number 5. 5 means how many numbers you want. Okay, so I'm generating my random numbers, right? I print my random numbers. It prints out these random numbers right here, and then I'm also calculating its mean value. Okay, I'm just trying to verify what the mean value is, and then I'm also printing the standard deviation. And as you can see, the mean value is 0.23, and my standard deviation is coming out to be 0.67. But remember what I just said over here. My mean value, I asked it to generate me a random numbers such that the mean value should be 0 and standard deviation should be equal to 1. On the other hand, when I calculate my mean, it came out to be this value, which is not 0. And look at my standard deviation, which is not exactly same as 1. And why exactly is this happening? Well, the reason the mean is not equal to 0 and standard is not closer to 1, that's because you are using a small sample. Okay, my size is only 5. If you work with a big sample, then your mean would be very close to 0 and your standard deviation would be very close to 1. So let's do that. So come over here. All right, so let's use sample size of 100 now. So I'm exactly same code, but now I'm changing my sample size from 5 to 100. Now if I run this and come down, and now you can see your mean. Look at that. Your mean is almost 0, okay, minus 0.009. And look at your standard deviation, 1.1, very close to 1. So by increasing your sample size, okay, by increasing your sample size, your standard deviation, when you pick up these your random numbers from your normal distribution, your mean is going to be equal to 0 and your standard deviation is going to be equal to 1. Okay, all right. Now same way you can sample from a normal distribution, mean equal to 50, and let's say five samples. You can do that too. So just come over here and let me create few cells. So let's say you want to do some sampling from a normal distribution with mean equal to 50 and standard deviation equal to 10. Okay. Well, in this case, you're going to do np.random.normal. You call this normal. When you specify your mean, log equal to 50, that's your mean value. Scale, that means your standard deviation is 50, is 10. That's your scale. And how many you want? 5. If you run this, you're going to get 5 samples over here. Now, clearly, if you calculate its mean, you calculate standard deviation, it will not be exactly 50, and the scale would not, your standard deviation would not be equal to 10. You have to increase the size. So once you increase the size, this will come out to be, your mean will come out to be closer to 50, standard deviation would be closer to 10. So likewise, you can generate binomial distribution. You can generate, you can have Poisson distributions. Then you can have, you can have uniform distribution. So binomial distribution, again, this is for mathematician. They will recognize this number 4, 5, 6, 7, 3. This is your binomial distribution. All right, this generates a binomial distribution. If you want Poisson distribution, then this is the command, this is the function to call. You specify your lambda, you specify your number of samples. Okay, number of sample is 10. If you want uniform distribution between 0 and 1, you actually say, you actually call this method dot rand, and you specify number of samples, 5. And if you want your uniform distribution between 5 and 15, okay, and it's going to give you the number of sample is 5, by the way. So it's going to give you uniform distribution between those numbers, and these are my corresponding distribution. This is my uniform, okay, uniform between 0 and 1, Poisson, and binomial. All right, gentlemen, thank you.